right, this is part 2 of our factoring quadratics mini lesson. This is typically taught typically taught in Algebra 1 and reviewed in Algebra 2. But today, or for this video, in the first video, we looked at a review of the distributive property and factoring using greatest common factors. In this video, we're going to look at the difference of squares and how to factor a trinomial with a equals to 1. So we're going to first start out by looking at some vocabulary. So let's talk about what this expression is and just kind of review some vocabulary. This is an expression with 3 terms, and so therefore we call it a trinomial. And it happens to be a quadratic trinomial because the highest degree or the highest exponent is a 2. So there's a couple of things here. This term with the exponent of 2 is called a quadratic term. The little number to the top right is an exponent, or some people call it a power. And the number in front, the 2, is a coefficient. It's the coefficient of the variable. Then we have the middle term, which is a linear term, the plain x term. It has an exponent of 1, but we typically don't write that exponent. It's just an understood 1, but that's the linear term, and that has a coefficient of 3. And then we have the constant term, which has no variables. It's a constant, and in this case, our constant's -1. Now we're going to start out by looking at a review of perfect squares. Think about what your perfect squares are. A perfect square is a number that can be written as a product of another number and itself. So 2 times 2, I can write 4 as 2 times 2. I can write 9 as 3 times 3. 16 is 4 times 4. 25 is 5 times 5, and so forth and so on. Here's a list of all the perfect squares up to 100. It's probably a good idea to memorize these or to make sure you have them readily accessible because they will help you with factoring. So to start out with, when you have a quadratic with no linear term, meaning that x term in the middle is gone. There's not one there. It's just got a quadratic term and a constant term. Oftentimes this will factor as what we call difference of squares. If it's a difference, if it's a subtraction, and if both terms are a perfect square, meaning it's an even exponent, the coefficient of your quadratic term is a perfect square, and the constant is a perfect square, then this factors to be very easily the product of the sum and the difference of the square root of each term. The square root of 1x squared is 1x. The square root of 16 is 4. So x squared minus 16 factors to be x plus 4, x minus 4. It's perfectly all right to write it as x minus 4 times x plus 4. Nothing wrong with that at all. So then over here, we've got some problems or some sample problems to try. First, you want to notice it's 2 terms, and it is a difference, and they're both perfect squares. So this factors to be the product, the sum and the difference of the square root of each term. And here we have perfect square, perfect square, perfect square, and it's a difference. So that's the difference of 2 squares, product, sum and the difference, square root of each term. And then finally here we have a perfect square and a perfect square. So that's the product of the sum and the difference of the square root of each term. This is often the easiest, it is the easiest quadratic to factor, but for some reason students struggle with it. I guess because it's so easy, it gets a little confusing sometimes. The next type of factoring we're going to look at is trinomial factoring. So we want to look at what standard form means first. So a quadratic is in standard form when it is in the quadratic term comes first, and then the linear term, and then the constant term. So the exponents are in decreasing order. And we typically identify the coefficient of your quadratic term. We call it A. Coefficient of your linear term is B, and the coefficient of your constant, or your constant term is C. So what we're going to look at here for factoring is how to factor trinomial, three terms, quadratic, highest degree is 2. So factoring a quadratic trinomial when the leading coefficient, the one in front of the x squared, is 1. This method is often called the AC method of factoring. And so I'm going to bring these up here. We're going to start out with, notice all of these have a leading coefficient of 1. Every single one of the ones in this section have a leading coefficient of 1. So we're going to start out by identifying those coefficients. A is 1, B is 7, and C is 12. So I've got them identified here. And this is called the AC method because we want to find two numbers that multiply to give us A times C, which is 12, that add together to give us 7, or B. So two numbers that multiply to give us 12, that add to give us 7, that's going to be 3 and 4. So then we can factor this to be x plus 3 times x plus 4. Sometimes you'll hear me refer to this as a magic pair. It's the two numbers that multiply to give me 12 and add together to give me 7. And then you can see how this works. So if I multiply it back out just to check, I get x plus 3 times x plus 4, do the area model multiplying, and I get what I started with. And that is why we talk about factoring being reversing multiplication or reversing distributing. So let's look at a second one. I'm going to bring this one up. Here we've got an A of 1, B of negative 4, and a C of negative 12. So we want two numbers that multiply to give us negative 12, that add to give us negative 4. And those two numbers are going to be positive 2 and negative 6. And so that factors to be x plus 2, x minus 6. And that is the factored form for that quadratic trinomial. Then we have 1x squared plus 5x plus 4. And again, we have an A of 1, a B of 5, and a C of 4. So we want two numbers that multiply to give us 4, that add together to give us 5. And that's going to be 4 and 1. 4 times 1 is 4. 4 plus 1 is 5. So this is going to factor to be x plus 4 times x plus 1. And then finally, we have this one. And this one is unusual because when we go through the process of listing out all the factors, trying to find all the numbers that multiply to give us negative 24, that add to give us negative 3, there aren't any. There is no pair of numbers that will give us negative 24 when we multiply that will add together to give us negative 3. So we call this a prime quadratic. We can only write it as a product of itself in 1. Just like 7 is a prime number, we can only get 7 by saying 7 times 1 over the set of integers, and or real numbers, or whole numbers, I guess. That would be a prime quadratic as well. So take a minute and see if you can do these on your own. First identifying A, B, and C, and then using the AC method to write each as a product of linear factors. And I will, oops, I have these all worked out here. that's got it. Almost. Oops. Can't make that. There we go. There. So we've got all the factored forms here. 1, 2, 3, 4, 5, and then we've got a prime here. And then finally, the reason we factor is so that we can solve a quadratic. Not all quadratics can be solved by factoring, but many of them can, and we can use the zero product property to do that. So let's go through these and see how that works. I'm going to go through each one of these. This will be a good review of all of them. So the first thing I want to do is make sure it's in standard form. A x squared plus b x plus c. So our a, b, and c are 1, 5, and negative 24. I'm looking for two numbers that multiply to give me negative 24, that had to give me positive 5, and I know those numbers are going to be 8 and negative 3. So then this factors to be x plus 8 times x minus 3. The zero product property says when you have two numbers that you multiply together, if you get a product of 0, one of the numbers has to be 0. That's the only way you can get 0, by multiplying. So if I know that these two expressions multiply together to give me 0, then I know either this first expression has to be 0, which means x must be negative 8, or the second number has to be 0, which means x equals 3. And if you were to graph this quadratic, you would see that it has x-intercepts at negative 8 and positive 3. All right, let's look at this one. Again, I want to make sure it's in standard form, and it is. There's no common factor, and so I'm going to go ahead and identify A, B, and C. Two numbers that multiply to give me 12, that add to give me 7. I know from a previous problem that's going to be 3 and 4. So this factors to be x plus 3 times x plus 4. And when two numbers multiply to give me a product of 0, I know that one of the numbers has to be 0. So either x plus 3 has to be 0, which means x would be negative 3, or x plus 4 has to be 0, which means x would be negative 4. And those are my two solutions. And again, if you were to graph that quadratic, you would see that it has x-intercepts at negative 3 and negative 4. And then here are the other two solved for you. Setting your quadratic equal to 0, making sure there are no common factors, and then finding your factored form, and then setting each factor equal to 0. And so we have a solution of x equals 6 and x equals negative 2 for this one. And again, if you were to graph this quadratic, you would see that it crosses the x-axis at those two places. And same with this one. You get solutions of negative 4 and positive 1. And if you were to graph that quadratic, you would see that it crosses the x-axis at negative 4 and positive 1. And then I've got several here for you to try. We've already done those. So yeah, that's it. That gets us to the end of the second video, day 1, part 2. And tomorrow's video, or part 3, will look at factoring using the area model and factoring trinomials where the leading coefficient is greater than 1.